This is Euclid Book 10, proposition number 99. The square on a second apotome of a medial straight line applied to a rational straight line produces as breadth a third apotome. Let AB be a second apotome of a medial straight line. So, this is the second apotome. And we're going to make CD, which is rational. And to CD, let there be applied CE. This area right here is going to be applied to this line. Equal to the square on AB. This area is going to be equal to this, producing CF as the breadth. I say that CF is the third apotome. We're not going to claim that this is the third apotome right across here. For let BG be the annex to AB. This is going to annex this. Therefore, AG and GB are medial straight lines commensurable in square only, which contain a medial rectangle. So, this and this are medial straight lines. They're only commensurable in square, and they contain a medial rectangle, which is by Euclid Book 10, proposition number 75. So, this is the medial rectangle. Let CH be equal to the square on AG. Okay? CH. That's this, this, and this. And it's going to be, all this area here is going to be equal to this. And let it be applied to CD, which it has, producing CK as the breadth, which is that's from here to here. Okay? And let KL, that's this little area right here, equal to the square on BG, which is this area right here, be applied to KH. Okay? This area here is going to be applied to KH, producing KM as the breadth. Therefore, the whole CL, okay, so that's this, 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 and this combined, is equal to the squares on AG and GB. So if you add these two areas together, you get this, 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 and this. Therefore, CL is also medial. So this, 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 and this combined is a medial area. That's by Euclid Book 10, proposition number 15, and Euclid Book 10, proposition number 23, porism. And it is applied to the rational straight line CD. It's been applied to this. And it produced CM as the breadth. Therefore, CM is rational. CM is a rational line. And it's incommensurable with CD. That's by Euclid Book 10, proposition number 22. Now, since the whole CL, that's all four of these combined, since all of that is equal to the squares on AG and GB, so all this area is going to be equal to this plus this. And in these, CE is equal to the square on AB. This is equal to that. Therefore, the remainder, LF. Well, what's the remainder? That's this, this, and this. It's equal to twice the rectangle AGGB. So, if we multiply this area by 2, we get this, this, and this. And that's by Euclid Book 2, proposition number 7. Let then FM be bisected at N. So this line is going to be bisected here. And let NO be drawn parallel to CD. This is now parallel to this. Therefore, each of the rectangles FO and NL, this rectangle and this combined, they are both equal to the rectangle AGGB. So this area is equal to this, and this is equal to that. But the rectangle AGGB is medial. Therefore, FL is also medial. Since this is medial, then these three areas combined are going to be medial. And it has been applied to the rational straight line EF. Okay, so now all this has been applied to this. And it produced FM as the breadth. Therefore, FM is also rational and incommensurable in length with CD. This is a rational line. It's incommensurable with this. That's by Euclid Book 10, proposition number 22. And since AGGB, okay, since this line and this line are only commensurable in square, therefore, this line is incommensurable with this. Therefore, the square on AG, which is this one, is also incommensurable with the rectangle AGGB. This is incommensurable with this. That is by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 2. But the squares on AG and GB, add these two areas up together, they are commensurable with the square on AG. So this area combined is commensurable with this. And if we take this area and we multiply it by 2, and then if we multiply this area by 2 and then we add it to this area, okay, therefore this and this combined are incommensurable with twice of this. This is by Euclid Book 10, proposition number 13. But CL, what is CL? That's this, is equal to the squares on AG and GB, which is these two. And FL, that is this, and this, is equal to twice the rectangle AG. So in other words, you take this area, you multiply it by 2, you get all three of these. Therefore, CL is incommensurable with FL. All of this area here is incommensurable with this and this and this. But as CL is to FL, as all four of these are to all three of these, so is CM to FM. So as this great big line is to this great big line. That's by Euclid Book 6, proposition number 1. Therefore, CM is incommensurable with FM. This line is incommensurable with this. By Euclid Book 10, proposition number 11. And both are rational. Okay. Therefore, CM and MF, this line right here and this line right here, are rational straight lines commensurable with square only. Therefore, CF is an apotome. This is an apotome. Okay. That's by Euclid Book 10, proposition number 73. I say next that it is also a third apotome. For since the square on AG, what's the square on AG? That is this, is commensurable with the square on GB, it's commensurable with this. Therefore, CH is also commensurable with KL. Therefore, CH, which is this, and this, is commensurable with KL. That. So that CK is commensurable with KM. So that this length is commensurable with this. This is by Euclid Book 6, proposition number 1, and Euclid Book 10, proposition number 11. And since the rectangle AGGB, that's this one right here, is a mean proportional between the squares on AG and GB, so this is a mean proportional between this and this, and CH is equal to the square on AG, so this, all these three together are going to be equal to that. KL is equal to the square on GB. This area is going to be the same as this. And NL is equal to the rectangle AGGB. What's NL? That's this and this. It's going to be equal to this area right here. Therefore, NL, which is this and this, is going to be the mean proportion between CH, which is this, and this, and KL, which is this. Therefore, as CH is to NL, as these three are to these two, so is NL to KL, so as this is to that. So far, so good. But as CH is to NL, as this is to this, so is CK to NM. So is this is to this. And as NL is to KL, as these two are to this, so is NM to KM. So as this is to that. This is by Euclid Book 6, proposition number 1. Therefore, as CK is to MN, as this is to this, so is MN to KM. So as this is to that. That's by Euclid Book 5, proposition number 11. Therefore, the rectangle CKKM, that's this one right here, is equal to the square on MN, that is 2. Okay. So this rectangle is going to be equal to this is going to be equal to this, and this happens to be the fourth part of the square on FM. Since then, CM and MF, this and this, are two unequal straight lines, and a parallelogram equal to the fourth part of the square on FM and deficient by a square figure has been applied to CM and divides it into commensurable parts. Therefore, the square on CM, which is this one, is greater than the square on FM, which is this one. This one's bigger than this. By the square on a straight line commensurable with CM, which is by Euclid Book 10, proposition number 17, and neither the straight lines CM and MF, neither this line nor this line, is commensurable in length with the rational straight line CD, so neither one of them are commensurable with that. Therefore, CF is the third apotome. This is the third apotome. This is by Euclid Book 10, third set of definitions, number 3. And that is the proof. Well, we have successfully made it through 3 more proofs. We're going to be using this diagram for 3 more proofs. And I will take care of that very, very soon. I will tell you more in a future video. Stay tuned.